I just want to take a minute because we've been talking about just kind of theory of calculus, how you find the maximum or minimum points of functions. And I want to just ask a quick question and pause the video and give it a little bit of thought. And the question is this anything anybody cares about? Why would you be interested in knowing the maximum or minimum value of a functions? Does anybody use this in the real world? So pause the video, give that a thought. So the short answer to that question is yes, it is important. And the long answer is yes, it is very important. Let me give you a quick example. Let's imagine that you were a book publisher and you were going to publish a book. The question you want to ask is, how many copies of the book should you publish? Okay. And I mean, if you publish too many copies of the book, you're going to have leftovers, and they're either going to be sold at bargain basement prices, or you're going to have to destroy them somehow. But if you don't make enough, you might not satisfy all the demand, and you might not make a buzz over your book, which otherwise might have sold more books if you had enough to kind of get that groundswell. So the kind of question that plagues you if you're a book publisher is, what is the right number of books to sell that's going to get me the maximum profit? And so what you would do is you would, either by trial and error or from collecting some data over a long period of time, you might make a profitability function that takes as its input the number of books that you published, and its output would be the amount of profit that you made for the book. And so once you've got a function like that, the question that you want to ask, what's the number of books that I would sell to make the maximum profit, is exactly finding the maximum value of that function. This is what we call in calculus an optimization problem. You're trying to figure out how to optimize the number of books that you publish to maximize your profit. Another thing that you might do is, if you are an engineer and you design cereal boxes. So what you want to do is you want to make sure that you're using the least amount of cardboard to contain all of the cereal that you want to sell to people. And there are some other, considerations that you need to do. It needs to be a box, probably, because you want to fill up a carton without having a lot of empty space. So those are the kinds of things that you think about. How do you optimize the shape of a box and the way that you cut out the cardboard and paste the things together to get it into that box shape while still using the least amount of cardboard? Once again, that's an optimization problem, but that time you're finding the minimum value, the minimum amount of cardboard that's gonna contain 16 ounces of your cereal. So optimization problems are one of the key things that we analyze in calculus, and it's might be the main reason why so many majors want you to have a little bit of calculus under your belt. Not necessarily because you're going to be calculating these derivatives in the real world, but you want to be able to have a conversation talking about optimizing, the situations that you will face in your career, and being able to express that in mature language, which is one of the things that calculus was designed to create. So these optimization problems, we're going to see them popping up very often, and it's going to be about calculating these maximum and minimum values by taking the derivative of the function we take care of, setting it equal to 0, and then using something like the first derivative test or the second derivative test to figure out whether what we've got is a maximum or a minimum value.